Hello, welcome to the course PH6B13E Computational Physics. The contents of this lecture is taken from Core Python Programming by R. Nagesh Rao. We will continue to discuss topics from Module 1, Introduction to Python Programming. In today's class, let's learn about control flow during a program. As we already know, program is a sequential execution of instructions from start to end. And there are three types of control flow. The most basic one is the sequential control flow. If you have a 10-line code, the first line will be executed, then the second line, then the third line, so one after another. So this is the default set. So if not instructed otherwise, the execution is always sequential. Now the sequential control flow can be changed in two ways. One, using a selective statement. Two, using an iterative statement or iterative instruction. Let's first talk about selective. So here a condition check is performed, and depending on the condition, certain instructions will be executed. And this is your if-else statement if you are already familiar with C or C++. So suppose you have a code like if a particular statement, then two instructions inside the if statement, then you have an else statement, right? So control first will go to the first line. If it checks the condition, if the condition is true, then it will go to the second line, which is instruction 1. Then it will go to third line, which is instruction 2. On the other hand, if the conditional statement gives a false result, then what happens? First it will go to the first line, that is the if statement. The condition is false, so instead of going into the second and third line, the control will jump to the fourth line directly, that is the else statement. So here the sequential control flow is disrupted using a selective statement. Same way, you can break the sequential procedure using an iterative statement. This is nothing but the loops. And here, certain instructions are executed repeatedly based on a condition. For example, if you have a for loop or a while loop of two instructions. Okay, so first line is the for loop statement. There you check for a particular condition. Inside that, imagine that you have two instructions. So line 2 and 3 are instructions of the for loop. Okay. So what happens? First control will go to the first line, and then it will go to the second line and third line. And after that, instead of going to the fourth line, what happens? Control will go back to the first line for the second iteration. So in that way, a number of iterations will be done. Only after that, the control will go to the next statement. So here also you are breaking the sequential flow of control using an iterative statement. Let's now talk in detail about the selective and iterative statements. First, let's talk about selective statements, which are also known as conditional statements. There are three types of conditional statements. First one is a simple if-else. If you are familiar with C or C++, the if-else statement you have learned there is nothing but the simple if-else in the context of Python. We have two more selective statements, that is the nested if and ladder if. First, let's talk about simple if-else. An if-else statement tests a particular condition. If the answer is true, a certain set of instructions is executed. If the answer is false, another set of instructions is executed. So this is the general syntax for an if-else block, a simple if-else block. So if conditional expression, then there is a colon. So here a particular condition is checked. So usually the conditional expression is written using relational or logical operators. Then inside the if block there is some instruction, either a single instruction or a set of instruction. Then you have the else statement followed by a colon. After that, the instructions corresponding to the else statement. Now, how does the Python recognize that this instruction corresponds to the if block? This is using the white space indentation. Just like the case of function, here also you leave a space so that Python understands that this instruction is part of the if block, or this instruction is part of the else block. Okay. Let's do a couple of examples. First one, a program to check parity of a given number. So how do you check whether a number is odd or even? Simple, you just divide it with 2 and look at the remainder. If the remainder is 0, then it's an even number. If the remainder is not 0, then it is an odd number, right? So here you can check, your condition should be to check the remainder. Now how do you find the remainder? You are already familiar with the modulus division, right? Modulus division gives you the remainder. So there are n number of ways you can do this program. Let's do using a function. So I am going to define a function known as print parity. So this function is going to do the job for me. Okay. So function needs an input which is the given number, right? Okay. So you define the function first. Define print parity in bracket the argument x followed by colon, and inside that I am going to test my condition. If x modular division equal to 0, remember this is not the assignment operator, this is the equal to operator. If x modular division 2 equal to 0 colon, then print x is even. And if not, that is your else, right? Else print x is odd. Okay, so this is how you define the function. Now you need to call the function. So I'm going to call the function print parity, then I'm going to give an argument like some number 15. Okay. So moment I call the function, the control will go inside the function. So it will go to the if statement, 15 modular division equal to 0. It checks this is not true. So the print statement will not be executed. Control will jump to the else statement. So here it will check whether 15 modular division 2 equal to 0. That is false, right? So this statement corresponding to else block will be executed. So you are going to get the answer x, which is the variable here. The value is 15. So your answer is going to be 15 is odd. So this is a simple if else statement. And one thing you have to note here is that the else statement is not mandatory. Sometimes you can get the job done only with if. Because what's the meaning of else here? So here you are checking the condition if x modular division equal to 0, right? So actual meaning of this statement is if x modular division equal to 0, whether it is true. That's a question you are asking here. On the other hand, in the case of else, you are asking the question if x modular division equal to 0 is false. In other words, if not, x modular division equal to 0. That's the meaning of the else statement, right? So instead of the else, I can actually use an if condition as shown here. So your first if is if x modular division equal to 0. Then you execute this. And instead of else, I can say if x modular division not equal to 0. Then you can say print x is odd, right? So else is not mandatory. As long as you check the condition correctly, you can get the job done in some cases with only if statements. Let's do another program using only if statement. Okay. The program to find the biggest among 3 numbers. So you have 3 numbers, you have to check which is the largest number. Okay. So you have 3 variables x, y, z. For now I am going to consider only integers. So once again, you can do a programming any number of ways. So if you want, you can input each number one at a time. So obviously that's going to take you more time. So you have to do it in the smarter manner. So the best way is to input all the 3 numbers at once using the split function. The syntax may be slightly complicated, but if once you get familiarized with it, it will become more and more easy. Okay, so this is the syntax. So you have the square bracket int x for x. X is a dummy argument. You can put any name here, it doesn't matter. In input, enter the 3 numbers dot split. Okay, so you can enter all the 3 numbers at once, separated by space. Now the biggest number I am going to call it as big, and I am going to choose one of the numbers randomly as the biggest number. Okay. So for now I am going to choose x as the biggest number. Then I am going to test whether x is actually the biggest number. If yes, okay, well and good. If not, I can change the value of the variable big, right? Okay. So next statement, if y greater than big. So I am checking whether the value of y is greater than x. If true, if y is indeed greater than x, now big equal to y. So y is the bigger number. Here else statement is redundant because if y is less than x, that is the meaning of x, right? If y is less than x, big is still x, right? So this is redundant. You don't have to explicitly use an else statement here. So next question, what about z? Okay, so I'm going to put one more conditional check if z greater than big. If this is true, then big is z. Z is the biggest number. If not, once again, the answer is redundant. The biggest number is x, which is already there. So in such cases where the else is redundant, you don't have to mention it. It doesn't mean that always an if should be followed by else. No. As long as the conditions are satisfied, you don't have to use the else statement. Okay. Now finally print the biggest number is big. Okay, so if x is, suppose the x is the biggest number. So what happens in the first statement? You assign the value of x to the big variable. Now in the second statement you are checking whether y is greater than x, and we know that that is not true. So it will go to the second if condition, whether z is greater than x, that is also false. So directly it will go to the print statement. On the other hand, if y is the biggest variable, the second line is executed, then it will check whether y is greater than x. That is true. So what happens? Now big becomes y. Now it will go to the second if statement, whether z greater than y. That is not true. So this will not be executed. Directly it will go to the print statement. So that's how the control jumps depending on the condition check. There's an assignment for you. Write a Python code to check whether a given year is leap year or not using simple if-else statement. Now what if you want to write an if-else statement inside an if block or an else block? This is known as nested if. So an if-else statement within another if-else statement is called nested if. The second if-else statement can be inside the if block or the else block. So this is the general syntax for nested if. If conditional expression 1 colon, inside that you have some instruction, call it as instruction 1. Then I will have an if-else statement inside the if block. So if conditional expression 2, then you have instruction 2, else, then you have instruction 3, then you have the else corresponding to the first if and the instruction corresponding to that else. So you have a number of if-else statement, connected if-else statement. So in this case, the if-else is part of the if block. Same thing you can do as part of the else block. So this is going to be the syntax. So basically you are having a number of if-else statement connected to each other. Now how does Python understand which else is connected to which if? So basically Python uses the indenting, the white space indentation. So here you can see else is at the same position as this if, so Python knows that this else corresponds to this if. On the other hand, in this case, this else is in the same position with respect to the spacing as this if, so it knows that this else corresponds to this if. So Python uses the white space indentation smartly to denote the if and else blocks. So you can club a large number of if-else statements using nested if, and an if block or an else block can accommodate up to 256 such nested ifs. Predictably, as the number of such loops increases or number of such blocks increases, the program gets more and more complex. Let's do one example. Write a program to find solutions of a quadratic equation with nested if. So you know the general formula of a quadratic equation, right? Ax squared plus bx plus c. And you have to find the solution for which values of x in this big equation becomes 0, right? And you know the general formula. The roots are minus b plus or minus square root of b square minus 4ac divided by 2a. Right? These are the roots of the equation. Now here you have three equations. One, b square minus 4ac, that is greater than 0, that is equal to 0, that is less than 0. These are the three conditions, right? So you can check those conditions using a nested if statement. So let's do the program. So in the case of such large programs, you can always type the entire program in the text editor instead of typing in the Python idle window or the interactive mode. Okay. So first you need to input the three coefficients a, b, c. So once again you can input them at once using the split statement as shown here. Or if you think that this syntax is slightly indirect, you can input each coefficient one at a time using the simple input statement. Okay. Now, whenever you do a program, you have to consider all the possibilities, because when you do a program, you are not the one who is going to use. The user is going to be a completely different individual, right? And if the user is not careful enough, or if he is not smart enough, he may make mistakes while inputting the numbers, right? So you have to take into account all those possible scenarios. So here, one thing that could happen is that while entering A, B, C, inadvertently, the user may put the value of A as 0. And what's the meaning of this? Ax squared plus bx plus c. When a equal to 0, your equation is bx plus c. This is not even a quadratic equation, right? This is a simple linear equation. So all the solution procedure you are going to do is not valid for that equation. So if by mistake user puts the value of a as 0, you have to tell the user that this is not valid. Or if you put a equal to 0, the equation is no more quadratic. That's a good way of doing a program, right? So you can put that condition first itself. So this is your primary if-else statement. So if a equal to 0, once again, this is the actual relational equal to. This is not the assignment operator. If a equal to 0, print the equation is not quadratic. Else, now you can discuss about various possibilities. So here the most important parameter is the factor b square minus 4ac, because depending on the value of this, you have different roots possible. So let's, instead of typing it each time like this, let's define it as a variable dis. So dis is b square minus 4ac. Now inside the else block, I have the first if statement. So here I'm going to check whether this is greater than 0. If it is greater than 0, I know that I have two roots. One is minus b plus square root of this particular term divided by 2a, and the second root is minus b minus square root of this term divided by 2a. Now to find square root, you can use a mathematical function sqrt. So since this is a mathematical function, before calling this, you need to load the corresponding module, the math module, onto the RAM. So that's why we start the program with from math import step. Since we are using only sqrt function, you can also write from math import sqrt, but it's always a good practice to load, to import all the function at once. So that's why I use the star here. Okay. Another thing, when you write an equation like this, if there is some confusion, you can always put brackets here, because if you don't put a bracket here, you may have a doubt whether this division will be performed first, then this multiplication will be performed. So if you, whenever you are in doubt, always put brackets. In that way you can avoid confusion. So So these are the two roots. Now we can say print the roots are real and distinct, just to give an extra idea to the user. Then you print the actual values of the root. Print the roots are root 1 and root 2. So the first condition is checked. Now you have an else statement, right? Else. Inside else, you have two more options, right? Whether this is equal to 0 or this is not equal to 0. Not equal to 0 means the only option left is this is less than 0. So first let's see whether this is equal to 0. So inside else I have the nested if. If this equal to 0. If this is true, what happens? These instructions will be executed. And what are the instructions? Now I know that my root is minus b divided by 2a, because this factor is 0 now. So I will print the roots are real and same, then print the value of the root. The root is root. And the only condition left is this less than 0. So that is your else statement here. Else. Now you know that your roots are complex, right? So it has a real part and an imaginary part. What is the real part? Minus b divided by 2a. So I'm going to call that as x. And what is the imaginary part? B square minus 4ac divided by 2a. Because since b square minus 4ac is a negative number, square root of that by default becomes an imaginary number. Now here you have to be careful about one particular thing. SQRT function calculates square root of only positive numbers. It doesn't calculate square root of negative numbers. Since this is negative, you have to make it positive by using negation operation here. So minus this, square root of minus this. So your y, the imaginary part, is going to be square root minus this divided by 2. So this is the real part, this is the imaginary part, and you can construct a complex number using the complex function. So your root 1 is going to be complex x comma y. So your answer is going to be x plus iy. Or in fact, Python doesn't use the symbol I, it uses the symbol j. So your answer is going to be x plus jy. And the root 2 is going to be complex x comma minus y, which will give you x minus jy. When you print the roots are complex and distinct, then you give the values of the root. Print the roots are root 1 and root 2. So this is how you test multiple conditions using a nested if statement. And the third one is ladder if. Once again, you have a large number of if-else statements. You can club them using the ladder if. So if you notice the nested if here, so if you look at this block, you have an else followed by an if. Right? So instead of writing them in two separate lines, I club the else and if together. Else plus if, this will become elif. So elif is the keyword for ladder if. So this is the general syntax. If conditional expression 1, then you have instruction 1 corresponding to the if statement. So if the condition expression 1 is true, instruction 1 will be executed. If not, it will go to the next line. So what actual meaning of elif is? Else if. Okay. So elif conditional expression 2. So if this is true, instruction 2 will be executed. Otherwise, control will go to the next statement. Elif conditional expression 3. So in this way, you can write a number of elif statements. And always this should end with an else statement which corresponds to your first if statement. So else the corresponding instruction. So the expressions are evaluated from top to down. If the first condition is true, the immediate block is executed and other conditions are not checked. So if the conditional expression 1 is true, instruction 1 will be executed. All these instructions are bypassed, right? Because there is no point in checking those conditions. If the first condition is false, the system will go to the next condition and test that, and this will continue. And as I said, ladder if always ends with an else statement. And one thing you have to note here, all the statements start with the same indenting. So in the previous case, depending on which if else statement, you have to leave corresponding space. So you have to leave the corresponding space depending on the nested if else, but here everything starts with the same spacing. Let's do an example. Write a program to find the grade of a student according to the following table using ladder if. So if the mark in percentage, if it is greater than 90, A grade, 80 to 89, B grade, 70 to 79, C, 60 to 69, D, 50 to 59, E, less than 50, no grade. So once again, if you want, you can do this using the nested if, but let's do using the ladder if. So here there is going to be only one input, right, which is the mark in percentage. So do that first. So I have a variable mark. I'm going to call it as a float. If you want, you can call it as an integer. So float input, enter the mark in percentage. Okay. Now you have to make the following test, right? Whether the mark is greater than 90 or mark is less than 50. So you do all that conditional checks using the ladder if. So first, the primary if mark greater than or equal to 90. Then you say grade is A. So here grade is a variable. This is a string variable or a character variable. If not, then what's the question? Then you check whether mark is greater than 80. You have to check this condition. So if followed by else, then you check using if, right? So else if, you are clubbing the else and if using the elif statement. So elif mark greater than or equal to 80. So now you know that mark is less than 90, it is greater than 80, then you know the corresponding grade. This is a B grade and grade is B. Same way, elif mark greater than or equal to 70, grade is C, elif mark greater than or equal to 60, grade is D, elif mark greater than or equal to 50, grade is E. And finally, if the mark is less than 50, no grade, right? So here, no more if statement will be followed, so you can end the ladder if using the else statement. So else meaning the grade is not greater than 50. That's the meaning of else, right? So you say grade is no grade. Then you say print the grade is grade. So depending on the conditional check, suppose if the mark is between 70 and 79. So what happens? It will go to the first if statement, this is not true. It will go to the second statement, this is not true. It will go to a third statement, this is true. So grade is C. Moment this is true, all other instructions will be bypassed. It will straight away go to the print statement. So you get the grade is C. So this is how the ladder if statement works. You can do a couple of assignment programs so that the concept becomes clear to you. So write a program to find solutions of a quadratic equation with ladder if. Okay. So we have done that program using nested if. Same program you can do using ladder if. Another program, write a Python program for a calculator using conditional statements. So you need not program a complex calculator. You just need to perform 4 operations. Given 2 numbers, you need to perform addition, subtraction, multiplication, division. So you have to input 2 numbers, and depending on the choice of the user, you have to perform one of these mathematical operations. There are n number of ways you can do this program. So first you need to have the logic. Okay, what is that you want to do? So here you need to do a conditional check, right? So first you need to identify what is the conditional check. You can do it in any ways. One thing could be like you ask the user what is the instruction he or she wants to perform. So he will enter it as a string, and you can check your conditional you can check the condition using the value of the string. Okay, you can check whether the string is a plus symbol, or string is a minus symbol, or it is a multiplication symbol, or it is a division symbol. That's one way you can do. You can do in whichever way you want. So first get the programming logic right. After that, you can think about how to implement it using the Python syntax. Okay. So do that assignment. In the next class, we will discuss about iterative statements, where we will talk about the loop instructions, mainly using the for loop and while loop. Thank you.